Hello, I'm Kevin, VK6 Lima Whiskey. Now, you may have recently built and installed a new antenna. You may have bought a new antenna. Either way, you're probably fairly keen to find out a little bit more about the antenna and its characteristics. And one of the more important factors is the SWR. A low SWR will indicate that your radio is transferring most of the power through the transmission line to the antenna. So there's some other factors that come into play here, and that is the line loss on the transmission line. But generally speaking, you're looking for a low SWR here in the shack. Now, there's a really neat device you can purchase that will help you with this, and it's called a Nano VNA. You may already have a Nano VNA. It's quite a small device, got a thumb wheel device on top for changing the frequency, and it's got a menu system which is relatively easy to navigate. Once you've taken a look at the help files, there's an awful lot of information available for the Nano VNA. But there's a piece of software you can download which helps enormously. The Nano VNA, as its name suggests, is pretty small. But you can download some software called Nano VNA Saver. And this helps a great deal because all of a sudden you've got all this information on a fairly large screen on your monitor. Now, there's a lot that the Nano VNA can do. It's not just about SWR. You can measure inductors, capacitors, bandpass filters, high-pass filters, low-pass filters. It's got a Smith chart function as well. It's a very useful test device. However, to keep this fairly simple, we're just looking at SWR at the moment, and I've just got 3 frequencies plugged in here. I'm testing my Delta Loop on-ground low-band receive antenna. Just taking a look, see what the SWR is like on this. The modelling looks fairly good. The SWR on the modelling looks great. But in real life, there's always going to be some variations on this. So what we're looking for is a relatively low SWR here. We're dealing with low frequencies, so the line loss on the transmission line due to SWR is going to be very low anyway. Anything under 2 or 3 to 1 on the low bands with the receive antenna is going to be absolutely fine. So you can see here that we've got the 3 markers, 1.8 megs, 3.6, 7.14. The markers got corresponding places on the graph here. And if we move these markers around, if I move the 160 meter marker, you can see that the SWR here varies according to the frequency, which is all as you'd expect. And if we take a look at 1.8 megs, you can see we've got an impedance here, 34 ohms, with a little bit of inductive reactance. It's not huge. SWR 1.474, that's perfectly acceptable. 80 meters, 3.6 megs, we've got an SWR 1.6, and 40 meters, we've got an SWR over about 2, which again is still very acceptable for a receive antenna on these low bands. A little bit of capacitive reactance here on 40 meters, but nothing really to worry about. So pretty happy with the way that looks. And this piece of test equipment is relatively inexpensive. Since I bought mine probably 4 or 5 years ago, there's been many other variations. They all pretty well work in the same way. The Nano Saver VNA can do a lot more than what I'm showing you here. There's a lot more graphs and a lot more analysis that you can apply to really any form of testing that you're keen to do in the shack. So, 73s for now from me, Kevin, VK6 Lima Whiskey.